Well, hello and welcome to this NASA Earth Data webinar titled Empowering Fire Managers, New HLS Capabilities in NASA Firms. Thank you so much for being here today. Just a few words before we begin. As you might have already noticed, the chat is open, so feel free to engage with your fellow attendees during this event. If you're going to interact with others, we ask that you do so in a respectful and professional manner. Next, AI bots like note-taking tools are never permitted in NASA meetings. So if we see any of those, we'll have to boot those from this meeting. Next, the recording of today's webinar will be publicly available in a couple days. You'll be able to find that on the Earth Data website and watch your inbox because we'll send that out in email as well. And finally, there will be a Q&A session today following the presentation. If you'd like to ask a question, make sure to post your questions for our presenters in the Q&A tab located at the top of your Microsoft Teams application or window. So with the housekeeping out of the way, I'm happy to turn things over to Jenny Houston.
Very much for the introduction, Jason. I'm Jen Houston. I'm a collaborator on NASA's Fire Information for Resource Management System, or FIRMS. I'm also the manager for NASA's Land, Atmosphere, Near Real-Time Capability for Earth Observation, or LANTS. I'll be joined during the question and answer section by Diane Davies. Diane is the manager for FIRMS, as well as the operations manager for LANTS. And I'm going to talk about the integration of the new Harmonized Landsat Sentinel-2, or HLS, menu into FIRMS. So I'll provide a quick overview of FIRMS, discuss the relevance of the HLS data in wildland fire monitoring and management, and then highlight the FIRMS HLS menu. I'm going to share a few short demos of the capabilities, and finally, I'll provide some additional resources that you can access to learn more about the HLS menu or FIRMS more broadly. There are actually two instances of FIRMS. There's FIRMS Global, FIRMS US Canada. FIRMS Global developed out of the original FIRMS from the University of Maryland in the early 2000s and was transitioned to NASA's Land, Atmosphere, Near Real-Time Capability for Earth Observation, or LANTS, in 2012. The FIRMS US Canada was developed in partnership with the USDA Forest Service. It was launched in 2021, and while the global instance has near real-time and real-time imagery and fire remote sensing products for the world, the US FIRMS Canada is more customized for the wildland fire context in the US and Canada. FIRMS really was established to provide satellite-derived active fire data for users regardless of their level of expertise, and it has really grown to a range of components and capabilities. I wanted to quickly highlight the blog as well as the extensive tutorials and the FAQs that we have available. So in terms of Harmonized Landsat Sentinel products and wildland fire management and monitoring, there are multiple uses, including informing moisture content of fuels and susceptibility to fire risks in a pre-fire context, facilitating small fire mapping. Just to note that the imagery is currently available with a 2 to 4 day lag, and therefore the lower latency HLS that may become available will be really informative for that. The data facilitate fire perimeter mapping in comparison with perimeter maps from WIFIX, for example, the Wildland Fire Interagency Geospatial Service, mapping the extent of burned areas, as well as performing change detection analyses and assessing burned area, as well as post-fire dynamics. Identifying patterns of burn severity is another use, and therefore supporting kind of post-fire response, recovery planning, and restoration management plans. The HLS menu in FIRMS includes both HLS Sentinel-2 as well as HLS Landsat 8 and 9, true color composites that are accessed via NASA's Global Imagery Browser Services, or GIBS, the false color composites, as well as selected vegetation indices that are relevant to wildland fire management are available in firms via the T-Tyler CMR, which is developed by NASA's Office of Data Science and Information. And CMR is NASA's Common Metadata Repository. And finally, there is the ability for users to visualize customized band combinations. So in terms of the true color and false color composite imagery, the true color composite imagery can be useful for quickly distinguishing surface types, features, etc., identifying smoke, clouds, cloud shadows, etc., that prevent satellite-derived active fire detection. The top thumbnail on the right is the mosquito fire in California. And as you can see in this true color composite, there is a massive amount of smoke that is really impacting the ability to see the ground. The false color composite can be really useful for identifying fire-affected areas, active fire fronts, as you can see in the V thumbnail. It provides much better smoke penetration, as you can see, facilitates burned area mapping and informs post-fire assessments. And just to note, this is the Landsat 30-meter active fire data on top of the false color composite. The normalized difference vegetation index, NDVI, a very common index, can be used to assess condition, health, and density of vegetation, as well as mapping extent of burned areas and assessing fire impacts to above ground vegetation. This is actually the Park Fire in California in 2024, and a big smoke plume up here. Normalized difference moisture index, or NDMI, this can be used to determine vegetation water content due to the sensitivity of liquid water in healthy vegetation, which absorbs in the 1.6 micron shortwave band, informing the moisture content of fuels. It can be useful in pre-fire risk contexts, and therefore the susceptibility of fuels to fire. The normalized burn ratio, or MBR, it commonly used in wildfire mapping, can be used to perform change detection analyses, for example, by combining before and after images, again, mapping the extent of burned areas and, importantly, the magnitude of burn severity, therefore supporting post-fire response and, again, informing recovery planning activities. And this is actually the Palisades fire, using an image from January 14th, 2025. The normalized burn ratio 2, or the NVR2, is actually a variant of the NVR that is highly sensitive to water in vegetation. And so by combining the 1.6 micron shortwave infrared and the 2.1 shortwave infrared band, we get additional information, and again, it can be useful in assessing post-fire vegetation conditions. And this is the National Fire and the Nordor Fire in Alaska, the Nordor Fire in 2024. And very quickly, the firm's team, in addition to Diane Davis and myself, we have three firm's developers, Dylan Mendez, Otmar Alsina, and Asan Radov. Our firm's US Forest Service partner is Brad Quayle, and Brad is instrumental in firms and in the evolution of firms, as well as two collaborators from the University of Maryland and NASA, Louis Giglio and Joanne Hall. And then the NASA official is Amy McNally. And I will leave you with this as we move to the demo. This is the advanced mode of the firm's interactive fire map. And if you click on these three horizontal lines, you'll see there are various modes available. The basic mode is the default mode. And back in the advanced mode, as you slide down, you will see the Harmonized Landsat Sentinel-2 menu. We're actually looking at a true color composite image from the 24th of April of this year, 2026. This is actually the Highway 82 fire in Georgia that started on the 20th of April. We're using Sentinel-2 imagery, and you can check that by toggling this on and off. In the true color composite, you can quickly see that we can identify roads, rivers, agriculture, etc. There's a significant smoke plume here, as well as clouds, cloud shadows, etc. However, the information available is rather limited. If we now look at the true color composite image of the same Highway 82 fire, we can see there's much better smoke penetration here. We can clearly identify areas that have already burned. We can also see active fire fronts here and here, as well as these isolated fire pockets in various areas. And if we pop on the US fire perimeters, so these are from WIFIGs, and we can actually see that this was very early on in the fire, and the fire actually covered much more extent. So again, that's the utility of the false color composite imaging. Here we're looking at the Dragon Bravo fire on the north rim of the Grand Canyon. This is a false color composite from the 29th of July 2025, and the fire here was started in early July. We're actually using a Landsat image here, and again we can clearly see areas that are already burned. Again, active fire fronts, isolated fire pockets, etc. I wanted to really highlight the utility of the 30-meter Landsat active fire data when they're available. As you can see, the 30-meter data really are able to pick up a lot of the detail on the active fire fronts. And if we compare this to the 375-meter VIAS data, as well as the Terra imagery from MODIS, we can really see the utility of the Landsat active fire data. And then finally, just let me turn these up. We are now looking at the false color composite equivalent of the MODIS 721 250 meter. And so you can really see the utility of the Landsat false color composite imagery. This is the Palisades fire in California in early January 2025. This is an image from the 14th of January 2025. This is actually the normalized burn ratio image here. The shades of orange are a burned area, and intense orange. So the more intense the orange, this is indicative of different degrees of burn severity. However, a couple of considerations are the sun angle, the low sun angle at this time of year, which would cause a lot of shadowing, as well as the range of topography in this region. This really highlights the utility of dynamic stretching, which is something we're thinking about in firms to help tease out degrees of burn severity. Next up, we have a normalized difference moisture index. This is a Nordor fire in Alaska. This started in mid-June 2024. And this is actually an image from July the 19th, 2025. So we can clearly still see the extent of the burned area. It's very visible, approximately 11 months after. That's identified by these different shades of red. And the more intense the red, especially in these upland areas, are indicative of lower moisture, which would be associated with dead or stressed vegetation, versus bluer tones, which are indicative of more moisture. And you can see some of the riparian areas here. And then finally, this is the Madre fire in California that started in early July. This is an image from the 19th of July. And I'm showing you this because I wanted to highlight the customized HLS band options that are available for all of the Sentinel bands, as well as all of the Landsat bands. Here we're using bands 8, 4, and 3, so the near infrared, red and green. The already burned area is evident due to the presence of things like ash, charcoal, etc. We can see dense vegetation in areas, as well as cultivation, agriculture, etc. These are red due to reflectance in the near IR and then absorption in the visible light. And finally, if we pop on again the US fire perimeter layer, and we've recently incorporated a rolling 12-month archive. So now we can see the Madre fire as well as the Gifford fire, which also occurred in 2025. And this type of information can be very useful for things such as current fires and identifying adjacent areas that may be previously burned and would therefore be more susceptible to burning. Okay, so that was an overview and tour of the HLS menu in firms. Again, it includes HLS Sentinel-2 and HLS Landsat 8.9. We covered the context in which the true color composite can be useful for things such as discriminating features, including roads, rivers, agricultural lands, etc., as well as highlighting thick smoke plumes or cloud shadows, which can all reduce the ability for a fire to be detected. Again, the false color composite, which is helpful in identifying already burned areas, as well as mapping burned extent, identifying active fire fronts and smaller isolated fires within a larger wildfire. The false color composite also enables better smoke penetration, which again in turn facilitates detection, and it can be useful in post-fire assessments. Then most recently, Firms has made available 4 vegetation indices or VIs that are relevant to the wildland fire management context. These include the normalized difference vegetation index, the normalized difference moisture index, the normalized burn ratio, as well as the normalized burn ratio 2. And over time, we'll potentially incorporate dynamic stretching of the vegetation indices into firms. And finally, Firms has incorporated the ability for users to actually visualize their own customized HLS bands based on combinations of the 13 Sentinel-2 bands or the 9 Landsat 8.9 bands. And the false color composites, as well as the vegetation indices, are all made available in Firms via the T-Tyler CMR service, which was actually developed by NASA's Office of Data Science and Information, or ODSI. And T-Tyler also makes use of NASA's Common Metadata Repository, or CMR. Okay, I want to spend the last few minutes sharing some resources that are available really to help users kind of further leverage Firms. I have a few slides and then I'll quickly demo these. So firstly, in terms of where to access Firms, there are several ways, but I want to highlight a couple of the main ones. So NASA Earth Data, and I've included the QR for this on the left. This is actually the main site for NASA's archive of Earth science data. And then within Earth Data, you can access Firms from NASA's Land Atmosphere Near Real-Time Capability for Earth Observation, or LANCE. And LANCE is NASA's Near Real-Time Data System, and Firms actually sits within that. And this is the QR code for LANCE on the right. You can also access Firms from the Data Tools section of Earth Data, and this is the QR code for that. Other resources to note are blogs and feature articles. We really make use of these to share updates, new data sets, new tools, etc. And we have an extensive FAQs page. And we have collaborated with NASA's Applied Remote Sensing Training Program, or RSET, on several webinars. Okay, for blogs and feature articles, again, for things such as updates, new data sets, new capabilities, etc., I've included the QR code for the NASA Earth Data blog, as well as the QR code for a recent blog that we just released about the addition of satellite swap outlines to Firms. And you can learn more about that with the QR code in the bottom left. And then in terms of feature articles, again, these are available through NASA Earth Data. I've included the QR code for the feature articles. And then the QR code for a feature about the T-Tyler CMR service, which underlies much of the HLS menu in Ferns. All right, moving on to FAQs. There is this extensive list available, and it actually includes a section on the HLS imagery in Ferns, and so I've included the QR code for that. And finally, these two recent trainings that we did in collaboration with NASA's Applied Remote Sensing Training Program, or ARSAT. This included an introductory series and an advanced series. These are available in English and Spanish, and you can share and access the slides and recordings using these QR codes. All right, let me now hop back over to the web, and I want to share a couple of additional demo options. Okay. So this is the NASA Earth Data main page. And again, it provides open access to NASA's archive of Earth science data. If you click on data, you'll see a link to LANS. Again, this is NASA's near real-time system, the land atmosphere near real-time capability for Earth observation. And Ferns actually sits within LANS. And then under the data tools section, you will find a direct link to Ferns. I want to quickly look at the LANS site, because I wanted to highlight two things again, that you can access Ferns from here, but also I wanted to note there are actually a range of near real-time data products that are available through LANS from multiple other satellite sensors, and these actually can be used to support a range of applications such as air quality and drought monitoring, flooding, severe storms, etc. All right, so I just wanted to highlight that. And then if we go back to data, you can access Ferns from here again, and that takes you to the main page of Ferns. From here, you can access the global fire map, the US-Canada fire map, which we used a lot today, as well as a range of other capabilities within Ferns that you can explore on your own. And then here is the link for the FAQs as well as contacts. And if you click on the FAQs, you will see there are a range of FAQs, and you can actually scroll down and there is a section on the HLS imagery in here. Okay, if I go back up to the top, I mentioned that there are blogs and feature articles that we make use of. And firstly, under the feature articles, you can see that the recent HLS article that I mentioned is available here. And so you can just go into the feature articles from the top, and you can actually filter the articles just to show those related to Ferns. So you can do that here. And then if we go up to the top again, and again under news and events, if you go to the Earth Data blog, you will see the Satellite Swap Outlines blog that I also mentioned. All right, and then for additional things such as the trainings, under the Learn tab, which is right here, and then trainings, and this one is a little more involved to navigate, but if you use the word fire in the search menu, you will actually just give it a moment. Okay, and you will see the trainings that I mentioned that were done in collaboration with ARSAT, including the introduction to NASA Earth observations and tools for wildfire monitoring and management, and then the advanced training series as well. Okay, thank you.
All right. Now it's time for us to move into the Q&A portion of today's event. I know we don't really have any questions at the moment, but if you do, put those in the Q&A tab or in the chat if that's easier for you. And then we will give our presenters a chance to address those for you. Yeah, so feel free to post your questions. We'll take a few minutes here and go into Q&A.
Well, thanks very much, Jason. I do see one question. What is the latency of the HLS product? There is actually a 2 to 4 day latency between satellite observation and the data being made available. And additionally, due to the repeat cycle of Landsat 8 and 9, when combined, that's about 8 days. And then for the Sentinel-2, it's down to 3 to 4 days with Sentinel-2 A, B, and C. But again, from the acquisition to the data being available, it's about 2 to 4 days. Is there an API access for VIA's false color composite similar to MODIS sensing? Okay, so the VIA's false color composite is viewable in WorldView, and then you would be able to download that using the Earth Data Search option. And Diane, do you remember what is available in Gibbs for that?
So the true color composite, it's available. I mean, it's available as an image, so you could get it as an API link if that was what you're asking for.
And the data false color
composite, it'll also be available in Gibbs, yes, as an API. So both of those should be there. And I'll pop a link in the chat to how to access those, if that would be helpful. So that would be through...
Sorry, Diane.
I was just saying that would be through NASA Gibbs, and I'll put the link in the chat. So,
all right, thank you. And then when can we expect more features from the USA, Canada firms to be available in the global firms? So again, the firms US, Canada was really developed for the US, Canada wildland fire context. And so if there is specific kind of contextual information available in there, it again is provisioned through kind of US agencies and covers the US Canada extent. As far as things like the Landsat active fire data, that we're always looking at different options to kind of expand coverage of different data layers that we have within firms. The HLS imagery, they're all available globally, but again, the latency on those is a consideration there.
Shall I take this one, Jenny? I was going to put in the chat about the false color composite in WorldView. I'll do that in a minute. But is there a way we could map the combined direction of the fire smoke and how long it's sustained in the atmosphere? So within firms, we have various modes. We have a basic mode, an advanced mode, and we also have one called smoke and aerosols. And if you go to that, you can look at the OMPS aerosol index product. And I'll try and put a link in the chat for that. At the moment, it's quite dramatic with the Canadian wildfires. So that enables you to see how long the smoke is in the atmosphere. So that would be a good first look for that. Yeah.
And just to add to that as well, that unfortunately one of the satellites, the SMPP spacecraft, is experiencing an anomaly at the moment, and so that is affecting any instruments on that satellite, including the VIA's instrument. as well as the OMPS instrument. And it is the OMPS instrument that we use for the aerosol index. There is also an aerosol index from NOAA 20, and so that is still available, and you will see that in firms. And there are 2 additional NOAA sensors, NOAA 20 and NOAA 21, that also are used to generate the VIIRS active fire data. So there are 2 additional sources of those 2 sources of active fire data are still available. So again, it's just the SMPP. And one thing that I don't think I highlighted is that at the top of the firm's interface, we do have an announcements tab, and that includes kind of an outages and data alerts pull down, and we do track outages, etc., on that page, as well as changes to those outages. So that's a good resource. And then finally, on the NASA Earth Data page, again at that top ribbon that I showed, there is a pull down there for the NASA Earth Data alerts and outages page. So that's another one to consult.
And I've just put the links in the chat so you can see the OMPS aerosol index in firms. You're welcome.
All right, I don't see any more, so we can go ahead and wrap up. Thank you both. Of course, we want to give a big thank you to Jenny and Diane for walking us through everything today. And if you'd like to share any feedback with us, earthdata-support@nasa.gov is how to do that. Thanks to everybody who attended live today. Again, the recording of this event will be publicly available soon. We'll send the video link to you by email, and you'll also be able to find it on the Earth Data website. And while you're there, be sure to check out all of our upcoming webinars and other freely available learning resources. We hope you'll join us again soon for another NASA Earth Data webinar.